Uh-oh. I'm not sure if you've had enough time with this or not. I'm going to give you about a minute more, but I just wanted to let you know that I have this big stack of quizzes that I haven't yet graded. And so I'm declaring a moratorium on collecting quizzes. So we're going to just go over this in just about a minute, and you're going to grade your own and know what you got and hopefully feel good about it. If not, you'll learn something from it. But I'll get these back. I've decided hopefully tomorrow morning I'll pound through this and then bring them on Monday, and then we'll have real quizzes from there on. So try to finish things up, and then we'll go over this together. Well, let's go ahead and see where you are. You might not be finished, but we'll finish it together. If that's the case, that's totally fine for this one. And hopefully on Monday I'll have things graded and ready to go here. So let's take a look at this one. Fill in the blanks. This first of all, the P there, that's think of that as being like the truth, or the thing that's true for the entire population, whatever you want to think of it as. As we move forward, we're going to be making predictions about the truth. That is to say, we won't know what the truth is, but we're going to gather statistics to hopefully point us to the truth. So this is what's true for everyone, is 211 out of 1298 CCP students. So that's that. P hat, on the other hand, is the symbol that we're using, and I left this up here. Oh, yeah, there's a little P hat there. That was the symbol we're using for the proportion in the sample. So sample proportion, just to distinguish it from the true proportion for everyone, we have the sample proportion. So for my sample, do I have a sample here? Oh, 17 of them, 96, yes I do, sorry. It took a minute to see, what is that? 17 over 96. Whatever number that is, it's like 0.177 or something. So you could have either one. It's fine. I don't mind decimals. In fact, probably the decimals are going to be helpful when we get down to the down here with all of this mess. So I believe this was 0.163. Is that right? Okay. Now that hopefully is easy enough. That's 96. If you put 1298, N is always going to be the size of your sample, who you're actually observing. I realize that there are 1,298 students at this particular school, but I'm just observing, if I was this math professor, I'm just observing 96 of them. So that's who I'm interested in, is the 96 that I can see and observe. Let's see, now we get into these two things. The sampling distribution for proportions has these. You'll need to be able to use those. Memorize? For sure this one. That one, I don't know how useful it is to memorize. We'll talk about it more when we get closer to the test. I know that's always a question. What do I have to memorize? Come on, you're all biology majors. You can handle it, can't you? Okay, not all of you are biology majors. But I'm always befuddled when I hear a biology major complaining that they have to memorize stuff for me. Because biology is all about memorizing, right? That's why I was so bad at biology. Anyway, sigma sub p hat. So that's the standard deviation of the sampling distribution. We actually have to do a little bit of math here on our calculators. So it's going to be the square root of p, that's this number, 0.163 times 1 minus that number, 1 minus 0.163, which is 0.837, all over the sample size, 96. So I don't know what that is. I probably could figure it out by looking down here. It must be 0.038. So this isn't a very good, I guess, example of, if this was on an exam, you could probably just figure out what the answer, like here, all those 0.038s. Anyway, getting back to this. All right, so we're good so far. Questions? Do you have any concerns? Hopefully you've all got 100% so far. Now for the tricky part, we want to actually answer a question. And the question we're trying to answer is, what is the probability that more than 17 CCP students are in this particular professor's class? Well, bear in mind that the middle, the sampling distribution mean is the proportion for the population, which is going to be that. And so 17 means more than a proportion of 0.177, which would be this. So make sure you actually do this. I'm not checking this for you. You're checking it on your own. But on the exam, I will be checking it. As we go forward with some of the work that we do when I finally do give you your quizzes, which hopefully will be Monday, I'll be checking this too. So make sure you put a line there. It's shaded. It looks beautiful, I'm sure. Okay, onward. So now we just have to pick the right answer. Oh, no, it's not picking the right answer. We're using these numbers. So let's see. The way that this works is we want to have the number. Yeah, I guess that the syntax here is confusing. Maybe this wasn't the best. Well, it's if you've done this a few times, you know that x goes here. This is going to be the mean. This is going to be the standard deviation. That last thing's always true. And so it's this last one that I'm going to be using. But 0.6437 is not the right answer. That's the number that goes over here, 0.6437. That's the portion of the distribution that's to the left. To get the stuff to the right, just do 1 minus that. And you get 0.3563. So hopefully you got 3563 as your answer. Coincidentally, it was this one, so I guess if you chose to just use that number, you'd get lucky, but on a test or a quiz, I'd kind of like to see where you're getting your number, so actually do the math on the paper. Some of you aren't good about that. You're just doing it on your calculator and just writing it down. But show me what you're doing so that I can give you partial credit if you get it wrong and full credit if you get it right. All right, questions, concerns? You can do this. It's not too bad. All right, excellent. So I was actually reading a draft of a paper, or it's draft of some guidelines, medical guidelines, and I came upon these sorts of things here. So notice that we have this, whatever, but the important thing is this stuff right there. See that 95% CI is 24 to 45%. And all the way through this thing, this draft of these guidelines for a particular treatment, all the way through, you see this these confidence intervals. That's what that is. It's a confidence interval. The reason why you find these in medical papers, psychology journals, biology, any science for that matter, business to some extent, is because we don't know the truth about an entire population. We just want to predict what's true. And so what these people are saying in this is that, I don't even know what this is. Oh, it's they responded to treatment. 83% responded to treatment in the sample. And then they say 95% confidence interval is 76 to 90%. What they're doing is they're hedging their bets. They're saying, we don't think that we know the truth. No scientist will ever say that they proved anything. No one knows what the actual number is for the whole population because we can't test every single person with this particular treatment to see if it works. But what we can do is we can test a sample and then make a prediction based on that sample, knowing that the central limit theorem works. So it's all about the central limit theorem and setting up this confidence interval. So this confidence interval, what they're saying is that they are 95% sure that the true percentage of people who would respond to this treatment is between 76 and 90%. Notice that means they could be wrong. There's a 5% chance that they're wrong. 5% of the time, these people are wrong. There's nothing we can do about it. That's the way the math works. Anyway, that's what we're going to be doing the next week, is learning about how to construct those sorts of confidence. It's really not that difficult. And in fact, today, if you can understand basically what I just said, then we're done. Well, let's just actually do something, though. Let me get PowerPoint here. Give me a sec here. That's not what we're doing. Should have gotten it ready while you were taking the quiz. Hold on a sec. Grab it. So basically, we're just going to see how the nuts and bolts are put together. Once I find the right thing, confidence intervals. Is this the one I'm using? I sure hope so. Just a sec. It's this one. There, 2024. Here we go. Okay. So confidence intervals is what we're doing today. Just the basics, just the basics. We're going to compute confidence intervals on Monday. Today we do just the basics, and we get to play a video game. Well, not really a video game, but I kind of felt like it was I'll show you. It's in the homework. I was overjoyed when I saw that Newton had updated their homework system to include this really cool thing. At least to me, it's cool. Okay, so this, first off, some definitions. Point estimate. We want to know the average for an entire population. What sort of average do you say? Maybe we want to know the average height of all people who live in the United States. Or maybe we want to know the average income of all workers in the United States or in some other country. We want to know the average lifespan of all people in a certain culture. Whatever. We're interested in an average, but we can't get that average. The average for the entire population is mu. We don't know what that is, and so what we're going to do is we're going to do the best we can by finding a sample and using X bar. And so we call that the point estimate. It's a point estimate for mu, for the average for the population. In the same way, the sample proportion, when I take a sample proportion of whatever it is that I'm interested in, maybe, nowadays, I don't know about you, maybe you don't get this, but I have been inundated by pieces of paper in my mailbox at home wanting me to vote for various people for who knows what, because apparently all that matters is the Republican, the primary is coming up. Yeah, so I went and voted so that and then they still send me the stuff. They don't know that I voted apparently. But anyway, I mention this because also in addition to that, I get phone calls from these people saying how great they are. And then I get phone calls from people asking me who I'm going to vote for. And so those phone calls that I get are people trying to figure out what the true proportion is for the entire population of, I guess, Knox County voters. But they can't ask every single Knox County voter, and so they choose to just ask a sample, and so p hat is a point estimate for p. I know, it's so simple. You use an average to estimate an average. You use a proportion to estimate a proportion. But the point estimates, they're statistics. They aren't the truth for the population. They're just true for the sample. And so we have to do something about that. And so what we do is we end up building a confidence interval. Confidence interval is just kind of hedging our bets, saying, I think that I'm within, a little bit of the truth. Just like that medical paper I showed you just a minute ago with the confidence interval. They're saying, what we got in our sample was 84, but we're going to just say that we think the truth is between 76 and 90. And even then, they may be wrong. It's amazing. But anyway, here's what you get when you do a confidence interval. You end up with a point estimate, either either P or X bar, whichever one. And then you have a margin of error. The margin of error is something we're going to compute on Monday. For today, we're just going to trust that it got computed correctly. I mean, that's how simple today is. It's really not much more than that paper I showed you, seriously. So I'm just showing you the pictures here. So point estimate minus the margin of error up to the point estimate plus the margin of error. In fact, it will look on the homework, you will see things almost exactly like this, except for they'll leave out this. It'll just be 76, 90. That's it. And they'll say that's your confidence interval. We'll show you some examples here in a minute. Okay, so here's what the confidence interval means in a picture. It's relying on the central limit theorem. And the central limit theorem says that when you take a bunch of samples, those samples are going to be on a normal curve on this continuum. Most of them will be in the middle. Some of them will be over here. Some of them will be over there. There's a certain probability that you'll have your sample close to the middle, which is what we would like. The middle is where the truth is, but your sample could be over here, but it could be out here. Now, we're going to be using alpha quite a bit. Alpha is the probability, in this case, the probability that the sample is outside this, oh, that's such a bad, sorry. I don't like that. I'm sorry. I'm going to change this. No, you've written already. Let's erase sample. I want to just flip it around. The parameter is outside the confidence interval. Okay, so this is what really is happening. What really is happening is that if you have a sampling distribution, the sampling distribution would look something like this. Most of the samples would be in the middle. If you get unlucky, you get a sample that's out here or maybe out here. So in truth, alpha is really the probability that your sample is outside this band. But in practice, what's going to happen is you're only going to have one sample, and that one sample is going to give you a confidence interval, and that one sample will, you'll have the probability that the parameter is outside the confidence interval. So it's really just another way of saying the same thing. It turns out that alpha is equal to 1 minus the confidence level. So if your confidence level is, say, 95%, then alpha would be 5%. If your confidence level is 99%, your alpha is 1%. We're going to be using alpha quite a bit for the rest of the course, but I just want to make sure that you're somewhat familiar with it, at least to begin with. I don't think it's even on your homework for this Monday, but that's sort of a picture of what's going on. So here's what we're actually going to do, is that we have, you'll have things like this, where you have this word problem that has way too many words for you to copy down, but let's say that we want to compute the mean amount of snow that a certain city receives during the month of April. And so she wants to estimate the population mean, that's mu, which is unknown because there's not a record for the amount of snowfall for every single year. So you might say, well, we know the average snowfall for Mount Vernon, but we don't, because we weren't keeping records back in the 1600s or something like that. Okay, so to estimate the unknown population mean, we're going to use a sample data to calculate the estimate. So the sample mean is this number. The margin of error, which we're just going to take on faith that it's been computed right, is 6. So what is the confidence interval for the mean amount of snowfall for this city in April? That's the sort of question that we're going to have to answer. I think you probably can do this without even any instruction, but let me actually do it for you. So in this case, you have the mean, which is the point estimate, minus the margin of error, and then the mean, 26.25, plus the margin of error. I know it seems so babyish, doesn't it? Don't worry, it'll get harder. But for now, it's pretty straightforward. So you have 20.25 and 32.25. And that's it. Starting Monday, I should start today, shouldn't I? But starting Monday, maybe I'll start right now. I'm going to have you write a sentence to describe this. Newton is lazy. They don't care if all you do is just write down these two numbers. I care that you understand what the two numbers mean. So here's what I'm going to have you do on, I'll have this in my PowerPoint Monday, but, oh, I'm sorry, I can't write a sentence for this one. We'll write a sentence later. There's a reason why I can't. I'm missing one key piece of information. So we're going to ignore the sentence for now. Okay, let's try this one on your own. So here's another example, kind of silly, but once again, you just have to use the numbers. You don't have to write all the words down. I'll read it over, though. A random sample of registered attendees were surveyed and asked if they learned anything new at the seminar they just attended. The proportion of those surveyed who answered yes was 0.52, and the margin of error was 0.04. You make your confidence interval, and I realize that some of you have already done it in your head. Just give me a second. I'll pick a rando to tell me your answer. There we are. Clayton, what's the bottom number of these two? You got two numbers, don't you? So what's the lower of the two numbers? 0. What was that again? I'm sorry. I see. Yeah, that's the margin of error. So margin of error. Okay, and then this is the point estimate. So that's going to be p hat right there. I meant the two numbers that you had in your confidence interval, but this is good. I'm glad you mentioned that we have to identify our numbers. I forgot to play the numbers game. We love the numbers game, don't we? Wait, did we do the quiz? We did okay, yeah, sorry. You know what? I'm blaming everything this week on the time change. So if I forget something, it's not because I'm getting old, it's the time change. I'm going to vote for any, talking about voting, I would vote for my least favorite candidate if he or she said that they would abolish the time change. Literally, seriously, that is the most important issue in my mind. Okay, maybe that's a bit of a stretch. There are probably more important issues, but it's up there pretty high. So anyway, we've got the margin of error and p hat. Now let's put these together. Let me remind you that what you're going to do to make your confidence interval is you're going to do p hat minus the margin of error. I'll just call that MOE for now. And p hat plus the margin of error. So I'm glad you did the numbers thing there to make sure that we understand where we're going. Thank you for that. So let's go on, though. Sophie, what do you think? What's the lower of the two numbers?
Like what the thing is 0.52 minus 0.54.
Mm-hmm. What'd you get?
What?
So what'd you get when you did
What
that?
I get, sorry. 0.48.
48. Very good, very good. So we got 0.52 minus, thank you for saying it out loud, though, so that if anyone's confused about where the numbers are coming from, 0.52 minus 0.48. Yeah, it's so simple that we're all getting a little bit confused on this one. But Emma, what about the bigger of the two numbers? What do you got? 0.56, beautiful. And that was 0.52 plus 0.04. I'm loving this. That's it. And so still, I can't give you a sentence because I don't have a particular piece of information. All right, so what you're going to be doing on your homework is, because that was so easy, there are a few sort of permutations of that question that we can ask. And so, for example, if you have a confidence interval and you want to know the margin of error, we can do that. If you have the confidence interval and you want to know the point estimate, we can do that. So anyway, I don't even know that we need to write that down. It's so silly because it's so easy. Let me show you what I mean by this. Here's an example. Suppose that we know this particular confidence interval. I want to know the margin of error. I'll bet you could figure that out without any instruction. I'll help you with this, though, just in case. So let me just show you how I would do this. Remember that this here, that number there, that is the margin of that's the point estimate. What is this? The mean height. So this will be x bar minus the margin of error. Hold on a minute. It's going to bother me that that's not in the same line. Margin of error. And this here is x bar plus the margin of error. Now, before you get excited that we're going to do some algebra here, let me just point out that x bar is in the middle of this. You could use algebra if you want. I know you want to set up a couple of algebraic equations. That's totally fine. Go ahead. But if you are scared of algebra like me, what you're going to do is you're just going to say the x bar, it's right in the middle. You just average those together. So in this case, x bar, my point estimate, is going to be 54.2 plus 56.5 all over 2. And so what is that? That's going to be 55.35. Hopefully I got that right. I'm scared of arithmetic as well, by the way. It all scares me. Okay, so I found the point estimate. I know it didn't ask me for the point estimate, but it's good practice because you're going to have to answer some of these with the point estimate. The other one, the margin of error. Margin of error. Once you have the point estimate, just use one of those. I don't care which one. Let's use that one. Let's see, x bar, 55.35 minus the margin of error is equal to 54.2. Oh, I just told you that we could avoid algebra, and apparently I'm going to use some right now. You probably could avoid algebra if you were clever, but I'm not as clever as you are. 55.35 minus 54.2 is equal to the margin of error. That's how I can avoid it, is I just recognize that that's in the middle, and the margin of error is the distance to either side. So all I got to do is do the difference between that and one of those two. So let's just do the difference between those two. And when we do that, I get 1.15 is the margin of error. And so the final way that you could write this is 55.35 plus or minus 1.15. Really not hard. I know I'm dragging this out because basically I don't have anything for you today. It's all boring. What about, sample mean? We already did it. So it's back here, sample mean. Well, that was easy. Let's do another one. Just a minute. I know you want to do it yourself. Try this one. We have the confidence interval for a population proportion, and I want to know the margin of error, and I want to know the sample proportion. So basically, it's the same two questions that we just answered. Take a minute, see if you can work it out. I'll bet you can. You're probably going to want to do this first. Find this number, because this is going to be p hat minus the margin of error, and this is p hat plus the margin of error. I'll find some rando to do it for us. Okay, let's see how we're doing. I know it's too easy. Hayden, what do you think? What is p hat?
P hat is 0.37.
How'd you get 0.37? That was quick.
I added up the 2 points inside of my.
Oh, yeah, because the p hat is right in the middle, isn't it?
Yes.
So it's always going to be right in the middle. Very nice. That's a beautiful job you did there. Noel, what do you think of the margin of error? I'll give you a hint. This particular, let's see, 0.41, that's the confidence interval, and right in the middle, that's where you're going to find the p hat. And so you just have to figure out how far it is to the edge of the interval. Yeah, go ahead and do it. Very nice. So you could go either way. You could either do 0.37 minus 0.33 or 0.41 minus 0.37. Either way you go, it's still 0.04. Very nice. Okay, let's see. I've got that to do. Let's do this first. Do this, and then I want to show you the video game that I was so excited about when I saw it. So when you look up gas prices, they show you an average. They say, oh, this is the average gas price in each of the states. And you can look this up on AAA.com, and and they say, here's the average gas price. What I find fascinating is that AAA doesn't actually go out to every single gas station in Ohio and ask them how much they're selling gas for. They take a sample. And the same thing is true of the government. So this is where AAA gets a lot of their data, is this government website here. You can go to that website, but I went to that website earlier today and double-checked that what I have in my PowerPoint is still true. And here's what they write. I love this. I would read the whole website to you if I could. I know, and I'm not that excited about gas-powered cars, but this is so cool. They say this on their, oh wait, first they don't say that. Here's what they say. This is so beautiful. I've got these things bolded here. Statisticians, they have this little statement. Statisticians use measures of sampling variability, such as the standard error and the coefficient of variation, to measure the sampling error. These measures of sampling variability are typically estimated from the sample that was selected. The standard error, which is measured in the same units, like dollars per gallon or gasoline prices, as the estimate, is a measure of the sampling variability of the estimate based on all possible samples that could have been selected using the chosen sample design. I love it. We're not done. We're not done. But notice what they said. They said, suppose everyone takes a sample. That's basically what that's saying when it says all possible samples that could have been chosen. If everyone took a sample, you'd get this beautiful normal distribution. They don't even say central limit theorem, but I'm just inferring. I'm sure that they're thinking it, even though they're not saying it. This has to have been written by a mathematician. But anyway, the coefficient of variation, also referred to as the relative standard error, is the standard error expressed as a fraction of, okay, I don't know about that, but where is it? There's something super great. Each average price, detailed price, standard error report. Okay, this is the one. This is the one that I love. Wow, so many words. What was I thinking? Okay, so many words. We'll skip. We'll just go to the bold stuff. Don't worry. And then I'll show you the video game. Oh no, I offended you?
No.
What, do you got to go play a game or something?
No, I'd rather be here as well.
Okay. No, you aren't kidding at all. You would rather be here. She offended me just as she loved. She almost got it out. But anyway, yeah, we're gonna all be. We're gonna follow her in just about 10 minutes. Don't worry, 9 minutes now. Okay, so this is from the government, getting this motor gasoline price. But here's the cool part: if a confidence interval were constructed for every one of those samples, the ones from the previous thing, the percentage of confidence intervals containing the census value, the truth, would be expected to equal the level of confidence. In other words, if you construct a 95% confidence interval, 95% of all samples would contain the truth for that particular variable or parameter. I just found that to be fascinating. They go on to talk about the margin of error, and they even say where the margin of error comes from, which we're going to have to go over this on Monday, so I'm going to skip that for now, so not to fret. And they even give you an example. If you have this number for your, I know if the gas prices were that low, that'd be amazing, wouldn't it? If that was your average, and this is your standard error is just the standard deviation of the sampling distribution, then you would compute the 95% margin of error this way. We'll go over this formula Monday. This is bonus material. And so on. So it's just, I just was so heartened when I saw that in this particular price report. Okay, I wanted to show you this so that no one gets too scared about this last bit. So most of this is really simple. It's going to be really easy to do. You might as well do it. In fact, we're going to be done in like 5 minutes now. Might as well do it now. Some of you probably already did it. You were doing it while I was blabbing. But this stuff, let's see, where are we? It's due on Monday. There it is. Confidence intervals A, B, C, and D, they're all really similar. Let's just preview this just to show you what it looks like. It's that last one that I want to show you about. So for example, here, it says, here's a confidence interval. What's the mean? And so you just figure it out by finding the middle, right? That's all you got to do. Find the middle number. Super easy. So look, I'll even cheat here and show you that that's what it is. So if this is your number, that's great. Okay, so let's close this because I want to go back. Can I close it? Yeah, I can just do this. It's this one I wanted to show you, this understanding confidence intervals. It's the last one for Monday. It's super, I think it's incredible. It's really cool. Let's see, preview as student. Here we are. So here's the question. So you have a question, and then basically all you have to do, so just want to make sure it's not confusing to you, all you have to do is adjust the little sliders here to match the information given. Just let me do this one with you, and then we'll be all done. So for this one, it says, bonuses of middle managers in the insurance industry are normally distributed with a population standard deviation of 1.2. Okay, standard deviation, 1.2. Notice what I'm going to do right now. Move this back to 1.2. See that? Next, it says the random sample of 35 middle managers. Okay, that means N is 35. Move this back to 35. It's a little touchy. And the sample mean is 9.8. So let's crank this up to 9.8. Will it go? One more. Oh. Feel like we could be here all day.
Yeah, you guys left like one little pixel.
Maybe if you reduce the sensitivity of your mouse so that you have to travel further, I think that might be better. Then it says, okay, you've got all this information. Find a 95% confidence interval. Click 95%. Oh, do I have to move it? I actually have to physically move it. That's so dumb. But anyway. Okay, and then it says round your, okay, so move the sliders and then round the answer. So there it is. That's it. That's your answer. So this is sort of simulating the calculations we're going to do on Monday. They're just showing you that we have this nice round, bell curve, and these are the confidence interval is what those are going to be. I don't know. I got to be honest with you. I don't know what those are. So I was trying to figure it out earlier, and then I didn't care. I didn't care enough, and so I didn't bother. But I'm not sure what those two numbers represent, but I can say that I can cheat and get the two numbers that they want, which is 9.4 and 10.2. That's all they really care about. So you can submit that and get your little confetti. But anyway, I love this because if you play with it, so you didn't see everything moving, but if you play with this while you're looking at, you'll see that things change. Like notice how the larger my sample size, the closer together these numbers become. So that's a really, big sample. If I go to a very small sample, then they're really far apart. So it's kind of neat that you can actually see things shifting dynamically there. All right, that's it. We're done early today. Isn't that exciting? So if you want to come and chat, you can. Otherwise, go and enjoy the